Thanks for coming to my presentation. Some people are coming in, no problem. I'm gonna talk about scaling 3D tiles. It's more about creating 3D tiles, how you can do that. In one of the previous talks, my colleague Stefan de Graaf was more talking about visualization of 3D tiles in Cesium, but this is more about creating them. A little bit about me. I studied at the Utrecht University in the Netherlands, geography, of course. Then I worked at Esri for about 9 years. And now I'm working at Socialink. In the slides, sometimes you see my previous company. It's called Geodan, but that one was acquired by Socialink recently. So Socialink, it's based in Europe, mostly in France and in England, and also expanding in Canada and Africa. I'm part of the innovation team at Socialink, and we do a lot of GIS and geospatial digital twins, and of course we use Cesium as our platform of choice. So a little bit back in the time, in 2019, we started looking at geospatial and 3D. At the time, and still now, there are two specifications available. One is E3S. Maybe some of you have heard of it. Yeah, there, one. It's good. It's by Esri. But it was for us very hard to work with, because basically you need Esri software to use this specification. So a better alternative for us was to use 3D tiles. At the time we looked at the ecosystem of tooling. It was not so much, but we used Pi 3D tiles and Cesium Ion. But it didn't really fit for us, because Cesium Ion, you have to upload all your data, and we wanted to have a little bit more control. And Pi 3D tiles, it worked well for small datasets, but not for very large datasets. So what did we want? We use Postgres as our favorite database. Of course, with the PostGIS extension. Then we want to create 3D tiles out of it, and then visualize it in, for example, Cesium.js. Now, 3D tiles is based on glTF, and one of my favorite libraries is SharpGLTF to read and write those files. So it's a reader and a writer. It supports 21 extensions of Chronos, glTF extension. And the one we use the most is the mesh GPU instancing. And I've been working on adding other extensions, 3D tiles extensions. The first one was Cesium primitive outline. And after that came mesh features, instance features, and structural metadata. And the last one was the most complex one, because it's so huge with all the types. So SharpGLTF has about 500 stars at GitHub, so it's quite active. Now here you can see how you can add an extension to SharpGLTF. As an input, you use the JSON schema. Those are defined. So those are the possibilities of the glTF extension. Then there is a tool called the processor, and a bunch of code is generated. And that you can use in your program. And then there is a second step, it's the registration. And some sample code. I've got 2 slides with sample code. Here you can see a triangle is created with SharpGLTF. So 3 vertices, a material is used, and then a glTF is created. So we've got a glTF with one triangle. And in this slide, you can see how we can add metadata to it with the structural metadata extension. So here a table is defined with one property. It's called a name property, and one value is set for the one triangle. And then it's saved as glTF. So based on this library, we created two tools. One is for 3D meshes. It's called PG2 B3DM. And the other one is for instancing. And this one is called i3DM export. Maybe some of you have used these tools. Not, yeah, some maybes. That's okay. So the first tool is about creating meshes. It supports 3D Tiles 1.0. At the time, B3DM files were created. Those are a glTF inside a binary file called B3DM. But in 1.1, there is only a glTF file. So we get rid of the B3DM name. So this tool makes a connection to a database, gets all the geometries out of it, and creates glTFs. And as an input, you can use all kinds of geometries, like line strings for pipes, for example, and polygons and polyhedral surfaces, and tints, and single parts and multi-parts. Implicit and explicit tiling is supported. And if the geometry is not triangulated, it will create triangles based on the AECO algorithm. Now, of course, all the metadata types are supported, and you can do a lot of shading tricks. So you can define shaders per triangle or per part of the geometry or the whole of the geometry. It runs everywhere on Linux, Windows, and Mac, and also Docker, so you can try it if you're back home. This project has almost 400 stars on GitHub. A little bit more about the metadata types. So there's a mapping going on between the type in the database, the attribute type, and the type in the 3D tile. Those are not the same. But most of the types are supported from Postgres. So a Boolean will become a Boolean. And the most are obvious, except the date time and the list of date time, because they don't exist in the 3D tile. So that's something to look at. And the other thing is the null data. Because in the database you can have null data values, but in 3D tiles it doesn't exist. There is only the no data value. So that's the value that represents the null. So that's a bit a tricky construction. So here we see a sample how to run this tool. So you have an input table. In this case it's very simple. It's a geometry with a polyhedral surface, a cube, and one attribute, and also an ID. And then you can run the console tool, PG2, B3DM, and as an input, your input table, and as an extra attribute, the A attribute, so we can display the name property, and then you can visualize it. So this is one cube, but the same method works for huge datasets. Now there are lots of other parameters we can use. I won't bore you with that, but you can look in the documentation on what it's all about. We can mainly divide it in the database connection, in the tiling method used, some styling parameters, And the projection, by default, everything is projected to the cesium worldwide coordinate. So it will work in cesium. But you can also use local projections. Then it doesn't work in cesium anymore. Some benchmarking of this tool. You must remember, if you have got a big data set, to create a spatial index. Otherwise it will be slow. And here I did the 10 million buildings of the Dutch buildings dataset. It took about 2 hours. And it depends a little bit on how many parameters you use for styling, for example. Well, this dataset is used at the PADOC registry. It's the Dutch registry with all kinds of geography information. And the first 3D tiles datasets are there. And this one is built using the tool I described. So it's about the buildings. About the styling. You can define the style in 2 ways. So either on creation time of the glTF, you can define the style of the glTF, or you can say in the client, in cesium, I use the styling language. And here you see an example of this second option. In this case, I visualized it, the buildings by building year. And yeah. So this option was getting more popular, but it only works in cesium JS and not in other clients, because they don't support the styling language. Here you see another example about subsurface pipes in London. So we have a line geometry in the database, and together with a radius, it generates pipes in the 3D tiles. And it's here combined with the Google photorealistic tiles. And another example about the subsurface, Stefan, who is sitting there, talked a lot about this, these views. Now you can also use the terrain together with the buildings. Here I also use the outline extension, so you see the little black lines around the buildings. With the terrains, I sometimes get a message from somebody who is saying, well, the buildings are about 50 meters above the terrain. And most of the time it's because of the difference between the ellipsoid and the geoid. So that's a very tricky topic for people to grasp, that there are several height measurements. But it can be solved. Now the other tool is E3DM export. It works the same, but this one only works on point geometries. And this tool is used for instances for like trees or putting poles or benches or cars or that kind of things in the map. It uses the glTF extension instance features and also structural metadata. And you can define per instance the rotation, so the jar, the pitch and the roll in 3 dimensions, and the scaling of the 3 axes. And here you see an example of trees in Grenoble, I think. Here a minimal example. There's an input table with a geometry. One model we use. There are some attributes, and the jar, the pitch and the roll is defined. Then we can run the tool, and the 3D tiles are created. And we can visualize it in cesium. Now, if you want to know more about this topic, you can go to the site 3dtilesnederland.nl. It got a lot of windmills, so it must be something Dutch. And here are some sample datasets. and also some quick start guides. So it's a very nice site, I think. Another project is called the Digital Twin Toolbox. It's created by Geo Solutions. Stefano is here. He is also on the conference, but not here. And he's behind this project. And this project takes the tools for creating 3D tiles meshes and instancing and put them in a Docker environment. And so you can start this project with Docker Compose up, and then you've got a graphical user interface to upload your data and tile it and visualize it. This one also supports point clouds. Now some current developments to round up. In the Netherlands we are very lucky with our point clouds because they flew the whole country like 5 times. We are a small country, so that's a bit easy. But we are now working in France, and they have their country partly covered. And we use these point clouds together with the building footprints to create 3D meshes. That's a complicated topic, but we have a tool called, or there is a tool called Roofer. And this tool takes the geometries and the point clouds and creates the 3D mesh. And here you see an example of Paris with the Eiffel Tower. So it looks very nice, but we are waiting for the point clouds to finish. Another development is textures and 3D tiles. This is City JSON with textures. City JSON is City GML, maybe you know it, but better because it's JSON. And this is from Rotterdam. They have a lot of these textured buildings, so we are playing with that. And the nice thing, we can also add the attributes now with the metadata extension. And another current development is the Gaussian splits. Here's a colleague has made a Gaussian split of his playing field for shooting things. So we are creating a tool to tile these splits into 3D tiles also, and then visualize it in Cesium.